I'm going to do a little capacitive review here. Now what I have here is a capacitive circuit, and a capacitive circuit is a little bit different than a resistive circuit because the series and parallel is opposite from what we learned in resistors. So if I was going to simplify this circuit, what I'm going to do is I'm just going to start and I'm going to draw it maybe. You got C1 in series with C2 in parallel with C3 and C4. So that's the way that I just redrew it a little bit so that it's easier to see. So C1 was 0.08 microfarads, C2 was 0.10 microfarads. Remember, that's micro, so we got to put some more zeros in there. C3 was 0.01 microfarads, and C4 was 0.02 microfarads. Okay, so when I simplify this, what I'm going to do is similar to the way I did when I did resistive circuits. This just stays the same, 0.8 UF. This stays the same, 0.10 UF. But this one gets combined into here. Now in resistive circuits and inductive circuits, we went 1 over this plus 1 over this, got it, and took the reciprocal of that. Well, capacitors are different. Remember, in parallel, they add. So if I add 0.01 microfarads plus 0.02 microfarads, I get 0.03 microfarads. Okay, so that's the way that works. And then this circuit right here gets condensed into the total. Okay, but it's not this plus this plus this like it was for resistors. Capacitors in series are solved by getting 1 over the total is equal to 1 over C1 plus 1 over C2 plus 1 over C3, etc. Right? So we got to go 1 over 0.08 plus 1 over 0.1 plus 1 over 0.03, and then we need to flip it. Okay? So if I take my numbers here and I go 1 divided by 0.08 equals plus 1 divided by 0.1 equals plus 1 divided by 0.03 equals, I then need to flip it. And if I flip it, I get my CT equal to 0.0179 microfarads. Okay? Now remember, that's pretty small. So this is 0.0179 microfarads. Okay? Now, if I want to get the capacitive reactance for this, what I would do is I would use the formula for capacitive reactance, which is capacitive reactance equals 1 over 2 pi frequency times C. So we're going to assume, I guess, 60 hertz here, okay? So remember, this is microfarads. So what I'm going to do is I'm going to start with that. I'm going to get 0.0179, and I'm going to go EE to the -6. Okay, so I got a pretty small number right there. That's what that number is. And I'm going to times it by 2. I'm going to times it by pi. And I'm going to times it by the frequency of 60. So I get a little bit bigger number. And then I need to flip it. And I'm going to get a really big number for capacitive reactance here of 148,189. Okay, ohms. That's what that would look like right there. And if I had my voltage here, I could then start solving for my currents, and I could work everything backwards that way. So there you go.